So one of the things I noticed, especially when you're in the space, you have a look at solutions like Toffee and some of your competitors out there. They come up with fancy and filigrane structures, but most of them are not manufacturable. But this is not the case with Toffee, right?
Yes, exactly. The problem of manufacturability, I think, is a shared pain in the field. There's always the fight of finding the soft spot between finding the best optimal design for operation. So the design that is physically the most efficient, and then finding the design that is efficient in the meaning of the user. So for the user, efficient doesn't mean the best heat exchange, the best reduction of pressure losses, for example. For the user, efficiency means, this design has to be light, has to be manufacturable within $1, for example, or has to be manufacturable with this machine and not with this machine. So this is really, even though it is an industrial problem, it's still a mathematical problem. It's just way bigger and way more complex. In the case of Toffee, we extended our technology really on the core, on the maths, on the model, to include this strong constraint. So literally today, the user can click from the platform, from the user interface, what is the manufacturing technique of choice and all the related parameters. For example, with Toffee you can create a design that are suitable for 3D printing, and you can select the resolution of the 3D printing, you can select the material, you can select the overhang, so to create a self-sustaining, self-supporting structure. And then for machining, for example, very similar. You can select that. You can select the tooling size, and Toffee optimize, so use the physics to drive the optimization within the constraint of your manufacturing technique. So really, the vision is creating design that are real, creating design that are manufacturable and really useful for the customer. So in this context, I truly believe that to be a useful tool for the customer, a tool that is accelerating the design cycle, there are two main ingredients. The one I just talked about, so the design, the output has to be real, has to be manufacturable, or at least very close to be manufacturable, and then leave to the engineer, to the designer, the last refinement, for example. And the other ingredient is the speed. The design has to be produced, the iteration has to be done in a short time. So I always talk to my team, when I have to align the next step, the next, let's say, decision in terms of development, with this word, like, guys, we need to, let's say, leave the black box mindset, something that I always call the black box mindset with my team. So we don't have to think AI, we don't have to think the new methodology as a black magic box. When we ask, we wait for days, for weeks, and then we have an answer. We need to create a tool that is accelerating. Our value is still the human, the people first, and we have to create a superhuman. So we have to create a mix of simulation, AI, data to accelerate the process of R&D and transforming really transforming the time the engineer is using, shifting from spending months on finding one suboptimal design to the time of the engineer using Toffee for navigating through many optimal design, many optimal trade-off between efficiency, between cost of manufacturing, and shifting the role of the engineer towards a more system level optimization. And I truly believe when you shift through a system level optimization, you literally see the problem more from apart, and you can tackle bigger problem. You can see more complexity, and this will make the step towards net zero, decarbonization, energy transition, etc.
It makes a lot of sense. From a theoretical, like how you explain it, it sounds too good to be true. But depending on when this episode goes live, we will have a deep dive session with Anto, one of your colleagues, and he will show ToffeeX in action, so people can actually ask questions interactively. It's going to be a dynamic session. So I think people have to see it to actually believe it. So I think that's going to be really, really cool.